A single mistake. That's all it would have taken. Nearly 300 meters beneath the sea, with millions of tons of water pressing overhead. One major failure could have turned this tunnel into a deadly trap. Yet today, thousands of people drive through it every day, without thinking twice. So how did engineers build the world's deepest undersea road tunnel and make it safer than many highways above ground? The answer wasn't bigger machines. It wasn't stronger concrete. And it certainly wasn't luck. It came down to one engineering decision, made years before the first blast. That's the story you're about to see. Long before construction began, engineers faced a problem no one could see. The mountain beneath the fjord was hidden. No satellite could reveal every fracture. No map could guarantee solid rock. The shortest route looked attractive. But underground, the shortest route can also be the most dangerous. Instead of asking, "What's the fastest way across?" engineers asked a different question. Where is the mountain strong enough to survive for generations? That single decision shaped everything that followed. But finding the right route was only the beginning. Because the real challenge started the moment excavation began. What was waiting inside the mountain? Every tunnel begins with uncertainty. Every blast reveals something new. Sometimes the rock is exactly what engineers hoped for. Sometimes it isn't. Deep beneath the fjord, hidden fractures carried water under enormous pressure. A crack only a few millimeters wide could become a serious threat. Removing water wasn't enough. The mountain itself had to be sealed. Engineers drilled thousands of injection holes. High-pressure grout was forced deep into invisible cracks. Only after the surrounding rock became stable could excavation continue. Progress wasn't measured by speed, it was measured by control. Then another invisible enemy appeared. Air. At nearly 300 meters below sea level, fresh air doesn't naturally circulate. Heat builds. Exhaust accumulates. And in an emergency, smoke can become more dangerous than fire itself. That forced engineers to design one of the most advanced ventilation systems ever installed inside a road tunnel. But even perfect ventilation couldn't answer the biggest question. After years of drilling from opposite directions, would both sides actually meet?
The sealing joints look stable. Check the sealant on section 3B. Checking the data now. I have a small moisture reading here.
For years, survey teams checked every measurement, again and again. Because underground, there are no second chances. When two tunnels meet after kilometers of excavation, even a tiny error can become a costly failure. Finally, the last wall of rock disappeared. The alignment was remarkably precise, but excavation was only half the achievement. The tunnel still needed power, lighting, drainage, fire protection. emergency escape systems, communications, continuous monitoring. Every system had to keep working every hour of every day, deep beneath the sea. Today, Ryfast carries thousands of vehicles through one of the most extreme driving environments ever engineered. Most drivers never think about the mountains surrounding them, or the enormous weight of water overhead. And that's exactly the point. The greatest engineering achievements don't feel extraordinary when you use them. They feel effortless. Ryfast isn't remembered simply because it's the world's deepest undersea road tunnel. It's remembered because it proved that with enough planning, precision, and patience, even one of nature's greatest barriers can become an ordinary road. If you enjoy documentaries exploring the engineering behind the world's greatest megaprojects, subscribe for more stories where impossible ideas become reality.